Hello everyone, welcome to my channel. So today's our problem is number of good leaf nodes pair. Alright. So what does the question state? So basically you are given a root of a binary tree and a distance, alright, and a pair of two different leaf nodes of a binary tree is said to be good if the length of the shortest path between them is less than or equal to distance. For example, if we take this example, there are four and three other leaf nodes, right? And the distance between them is 1, 2, 3. All right, and the given distance value is 3. So 3 is less than or equal to 3. Yes. So what we will do? We will simply increment. We will take one answer variable where we will count the number of good pair of leaf nodes, right? And answer we will increment it by 1, and I will simply return it, right? 1. Here, distance is 3, right? And this is the binary tree. So what are the leaf nodes? 4, 5, 6, 7, and what we have to return the good pair path, right? So basically we have to return the path of the leaf nodes whose distance is less than 3. So here, if these two are the leaf nodes, distance is 2. So it is less than equal to 3. Yes, so we will increment our answer variable with 1 for these particular leaf nodes. What are could be the other paths? One path could be this, right? And one path could be this, right? But here 1, 2, 3, 4, and similarly 1, 2, 3, 4 for this path. It will be greater than 3. So basically we will not increment the answer value, right? Now, what could be the other paths? One good path could be this, and what could be this? Again, 4 is greater than 3, so we will do nothing. Now, we will come to here. This path, yes, this path is values is 2, which is less than equal to 3, so it is a good path. So we will increment by answer. So answer value will be incremented by 1, so it will become 2, right? So we will return 2. Hope you have got this problem. See, now I would like to add one more test case, right? Suppose this particular 3 value, instead of distance 3, if it is 10, then what could be our answer? So this could be our answer. 2 is less than 10, right? This could be our answer. 4 is less than 10. This could be our answer. 4 is less than 10. Again, this could be our answer as 4 is less than 10. Again, this is also 4 is less than 10, and for this 2 is less than 10. So what could be our answer? Our answer value would be 6, right? Now, see one thing. So basically, what we have to do is we have to keep the track of all the paths, right? Because see, if the distance value is 10, then this could be also our path, right? So this path and this path until this root node both has the possibility to be to be a good pair of paths, right? Because distance is only 2, which is less than 10. Now if I get any if from here also, if I get the distance, I will get multiple distances, right? Multiple paths, right? If I get multiple paths that have also less than equal to 10 value, that could be our answer. So basically we have to keep the track of all the paths. So and there could be multiple paths, right? So suppose if there is 8, 9, 10, 11, 12, 13, 14, 15, these values are there, then how many pairs are there? There are 8 leaf nodes, right? So basically, what data structure we will be taking? We will be taking vector, right? Because we can simply increment the vector according to this size, right? That's why. So the whole idea about this example is which data structure we will be taking using for solving this problem, right? So what I will do is I will do nothing. I will simply use a post order traversal. Okay, whenever I am at now, whenever I am this particular leaf node, right, that is there is no left and there is no right, then I will return a vector of what? Containing a value 1, because the path size is 1, right? And if I am at null value, if roots left is null, then what I will do, I will return a vector which is containing a value 0. Okay, hope you have got it. Now, if you are thinking, like if we are checking if particular root left and right, if particular root value, if left and right doesn't exist, then we are returning 1, then why we are moving to the null? Suppose if there is no 5, right? So basically it is having left, but it is not having the right, right? So when there could be a possibility that we will move to the right, right? So it will be null. So we will return a vector of 0, containing 0. So this is basically, what is this? This is our base conditions. If root is equal to null, we will return a vector containing a value 0, 0. If root left is null and right is null, then we will return simply 1. Okay, hope you have got it. Now, what we will do, these are our, we have written our base case. Now, what we will do, we will simply traverse, we will use a post order traversal. That is, we will move to the left and we will move to the right. And after this, we will get a particular vector value, which I will store in left, right, L for the left root and left subtree, and R for the right subtree. Okay. Now, what I will do, suppose we are here. Okay, suppose we are here. So, first I will check the root, check this particular case, like the base case. Whenever we move to this 4, its left is null and its right is null, so it will return 1, right? Similarly, for this, it is left is null and its right is null, so basically it will return a vector of containing a value 1. Okay, you have got it. Now, where are we? We are at this particular node. Sorry. So we are at this particular node, right? What I will do, I have got two vectors. L is containing 1 and R is also containing 1 at this particular node. I will traverse through left, right, and then I will, in the inner loop, I will traverse to the right, because at now it is containing one values. At there will be some cases where they will be containing multiple values, right? And at this particular point, I will check whether I and j exist, right? That is, both are 0 or not. So here it is 1, it is 1. So it will condition, this condition will pass, right? Because it will be 1, and I plus j, that is 1 plus 1, is less than or equal to distance, that is 3. Yes, so we will increment the answer by 1. So for this particular subtree, we have received our answer, right? That is, this is a good path, right? So we will increment the answer by 1. So our answer value is 1 for now, for here, right? Up now we have to return some value, right? So what I will be returning, I will make one vector, right? And I will check for the left vector, if I is not equal to 0, but it was containing 1, so it will, condition will pass, and I plus 1 is less than equal to distance, that is 3. Yes, that is, earlier we are having 1 plus 1 is 2, that is less than equal to distance, so we will push 2 into our vector, right? And here also we were having one value and 1 plus 1, right? 1 plus 1 is less than equal to distance, so yes, we will push 2 into our vector. So basically here the path distance for this is 2 and the path distance for this is 2, right? And 2 is less than equal to 3. So basically we have, for here it will receive a vector of 2 and 2, right, from this particular tree, right? And similarly we will move to here, we will check, like it is right, post order, right? So before moving to here, we will move to here, right? And again for this, answer would be 1, right? So answer value would be 1 plus 1 is equal to 2, and here what we will return, similarly we will return 2 and 2, 2 and 2 from here and 2 and 2 here, right? And after this we will receive for this root node 2 2 and 2 2, right? For left it's vector containing the 2 2, and right also it's containing 2 and 2. We will traverse for each condition. See, for each condition 2 plus 2 would be less than is equal to 3. No, so it will fail. So suppose this is 2 and this is 0th index is also 2. One for one index is also 2, so 2 plus 2, right? It will also fail. Now I will move to one index of this particular vector, that is also 2, and here I and 0 is 2. So basically what we will get, 4 4 4 4, which is less than or equal to 3. So answer value won't increase, right? And after this, what we will return, we will simply return this particular vector by concatenating it, right? And answer value is 2 only. So at the end, what we will do, we will return our answer value, right? So it is not that tough, right? Hope you have got the problem, right? And hope you have got it why we are returning 0, right? Suppose this node is not here. Then when we will move to this particular thing, then it will return 0, right? And suppose, and why, for if someone is asking why I'm using this check, right? See, if this is 0, that means we have to reach the null value. So we won't increase, we won't mention it, right? That's why I am using this check here. Hope you have got it. Now, if I run this particular code, yes, it is running fine. And if I submit it, yes, it is accepted. So hope you have got the solution. See you in the next video. And if you like this video, please like it and subscribe. Thank you guys. See you in the next video.